We are building the Connect 4 project from the YByte Python curriculum available at www.ybyte.in. We are now at a very interesting point in the code where we will start writing functions to determine, let's say, the different types of winners. In this video, we look at creating a function to determine horizontal winners, which means winners, let's say, along a given row. Now remember, our strategy is to check the entire board, which means basically what we have to check is that on every row, we are going to see if we have a winner coming from, let's say, the cells as shown below. For example, we could have a winner on any row, which is spanning column 0, 1, 2, 3, column 1, 2, 3, 4, 2, 3, 4, 5, and 3, 4, 5, 6. Which means that on every row, potentially there are four positions in which we could have winners. And since there are 6 rows in all, there are possibly 24 possibilities that we have to look for. But of course, the way we will write our code, once we find a winner, we will just break so that it remains efficient. Uh, Now, our strategy, as we discussed earlier, is to extract a small list of 4 values. Obviously, this is a graphical representation, but behind this, as you know, there is a two-dimensional list called board. From that list, we are going to extract 4 values which correspond to, let's say, for example, let's say these 4 cells or say these 4 cells. On every row, we're going to expand, let's say, extract, let's say, 4 values, say 0, 1, 2, 3, then 1, 2, 3, 4. And then we will use our function, to determine if this mini list that we have created, if its values are all equal and if they're equal to the value that we were looking for. Because if that is the case, then we have a winner. Now let's see how we can do this in code. In fact, it's quite logical. It just kind of follows from our discussion here. Basically, we are going to start with a Boolean variable called, let's say, winner. I set it to false. Now I'm going to look in every row. So that's why I have this JJ going from, let's say, 0 to n rows minus 1, because really we're looking in every row. However, remember on the column side, we are looking at only column 0, 1, 2, and 3, because only those are the 4 potential starting points for the mini list that we are creating. Now, for each of these, which means, for example, for KK being 0, KK being 1, and so on and so forth, I create a list, I initialize an empty list, and then I look for the next 3 values along that row. Now, this is very, very important. Notice I'm saying board JJ KK plus CNT, which means JJ is really coming from the outer loop. For a given JJ, I find a given KK. Now, for having found the JJ and KK, then I say board JJ KK plus CNT, which means KK plus 0, KK plus 1, KK plus 2, KK plus 3. Think about it. This is basically a horizontal section on that given row. So it's now, having formed this list, I just go and check myself if all the values are equal to this value, in which case we have a winner. Now, obviously, value will be 1, for example, for the player, 2 for the computer. And having done this, I return the winner. Now, notice something interesting, that once I find a winner, I have a break statement here. In fact, I also have a break on the outer loop, because basically this break will break from the inner loop, which means that it will break on that specific row. But having found a winner, there's no reason for me to search for further rows, and hence I also break from here. So that's my outer, let's say, break. All of this will become more clear once we see this working in code. So let's just go and code this. I come back to my, let's say, my function that I've been developing here. I come back here to my code. I define a, let's say, a function called, let's say, check, check horizontal winner. And of course, I pass in a value because value will be 1 or 2 depending on if I'm checking for player or, let's say, computer. And I just put a small comment, scan the entire board for any horizontal, say, winners. Now, like we discussed, I define a Boolean variable, set it to false, and now I look for winner in every possible row. So I just say JJ in range, let's say, n rows. However, my columns, I will look for the starting point of the list in columns 0 to 3. So that's why I have for KK in range 4. Now, having done this, I will create an empty list. So I just create an empty list. Now, to populate this list, remember I start from this KK and I go along that row. So I just go and say, well, for say CNT in say range 4, um, I will go and say cells dot append board JJ. Notice I'm stay on the same row, but I do KK plus say C and D. So that forms me, let's say, the four items on that cell. Um, of course, for now, I can just print the cell so that we can understand what's going on here. And then having formed the cells, I just ask myself if, let's say, all same in the cells and the value. So the value comes from from the outside. If this is the case, well, then I have winner. I set winner to, let's say, true. And of course, once I have found, let's say, winner on a given row, then there's no need to search further on that row. I will just put a break statement. Notice this break will break me out from the inner loop, which is this, which means I'll no longer search on that row. But like I mentioned earlier, I would also want to break off from the search completely. I won't want to search any rows further. So I just go and put a small comment, put a small code here saying that if winner, then let's say break, right? So that's kind of logical, right? And having done all this, I will return, say, so I'll return a winner. Now let's see this working. When I run this code, of course, all my board is all completely empty, but I can go and let's say, put some values artificially on the board. So let's say I go and say 5, say, so row number 5, third column is 1, fourth column is 1, say fifth column is 1, and also say the sixth column is 1. So when I look at the board now, notice it's got 4 ones in a row over here, which means we have a winner. If I look for horizontal winner now, say check horizontal winner for 1, I expect to see a true. But more than just seeing a value of true, I also want to see what's happening on the list cells. Remember, we are printing that list cells from the function. Basically, I go through this list. I first form, let's say, these 4, then I form these 4, and so on and so forth. Then I form, let's say, these 4, and finally say these 4, and so on and so forth. I keep doing that. Obviously, there's no winner there. When I get to the last row, notice I start forming 0001. Then I look at 0011, 0111, and finally I have 1111, and I have a winner. Hence, I get a true. Now let's say I do something a little bit artificial here. So let's say I create one more winner in, say, row number 1. So I just go and say, well, look, my board 1 is 10 is, for example, 2. My board 1 is also 2. Now clearly this is artificial because we cannot have, let's say, coins staying on that row where other rows are actually empty. But just for the sake of testing this, so when I look at the board now, notice I've got a winner right here in this row. When I, let's say, run the code now, if I look for a winner in 2, you notice that I found the winner. I really did. And the code ended the moment I found the winner. That's because I had a break statement both in the inner loop and the outer loop. Let's just go one step further. Let's say I change this just a little bit. So I make, for example, 1 0 to say 1, but I do board 1, say 0 1 2 3. So board 1 4 to, let's say, 2. So now when I display the board, it is a little bit different. Notice I do have a winner here, but it's not on the very first KK, right? When I run this piece of code, again I do this. Notice this time around I went a bit further, but then I stopped again, and that's exactly what I wanted to do. So clearly this function is working, and that's the whole idea. Notice how we are indexing quite nicely to get it all in place. Before wrapping this up, I will just undo this print, so I don't think we need this. Also, in case you're wondering why did we not use slicing over here, well, in fact, you could have used slicing. That's not wrong, but I'm just keeping it this way because I want to keep the code homogeneous between all the 4, let's say, winners. So when we check for diagonals, for example, it'll be easier to do it with a for loop. So that's the reason I have done it this way. I hope you found this interesting and logical. In general, it's my firm belief that when we work on projects that are interesting, we learn much better. And that's what we're trying to do here at YByte. Look at our website, www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye-bye.